So continuing from the previous video, the real question now is where to define or implement this thing, given that we need this application to be flexible in order to accommodate this behavior only for the birds like parrot and peacock which support that. So this is all about contract setting. I know I haven't really explained what is the use of having a contract like this when it is actually not providing any implementation. And I'll be answering that when I show the polymorphic version of this main program. So until then, you just need to bear with me. So in order to solve the problem of this sing behavior, let me introduce what is called as an interface. So this time instead of class, I'll just pick an interface and I'll call it with something like iSingable. So interfaces are generally prefixed with the letter I, and you'll find phrases like this: iSingable, iPrintable, iResizable, thereby denoting the objects which actually support this behavior. It is not a must to have this, but it's a very good naming convention so that your code is very understandable. So I'll just go with this iSingable and probably also put it in the same namespace. And here I'll just define the sing method. It basically returns a void and takes nothing. But if your method was doing something more than this, you could specify the return type and input parameters as well here. But for now, let me keep the example simple. And you don't have to mention public because all the methods in an interface are public by default. Now, one way to think about an interface is as a pure abstract class. What does it mean? If you look at the actual abstract class we saw before, an abstract class can have methods which have implementation and methods which don't have implementation. So you can mix both. Whereas in the interface, traditionally, we don't provide implementation. So it is just there for the sake of contract. The implementation will be provided by the specific child, which will actually be doing it. What is the use of it? Again, I'll be explaining that a little later. So let's go ahead and continue this. Now, coming to my parrot class for whom I want to give the singable behavior, I'll just go ahead and say I singable. So the moment I do, there is an error. It's because my parrot class is not implementing the contract. It's not adhering to the contract set forth, which is basically it should provide the implementation for iSingable. So I can do it manually, or I'll just let the editor fix it. So I do have this now, and the error is gone. So here, I'll assume that we'll go ahead and implement the code in order to make the parrot sing. And let's say, again, we'll use a string interpolation operator. And we say name. So you see name is still accessible. That is something which was defined in the grandparent animal. Is singing, S-I-N-G-I-N-G. Singing, and we'll just say dot here. And how do we invoke that from the main program? As usual. So if I come here, I'll come here and I'll just say parrot dot sing. So I'll save it. Let's ensure that we are able to get the same output plus the additional output of the parrot now being able to sing. There you go. Glory is now able to sing as well. And what happens if there is some bird which does not implement the singable interface? Let's say we will want to have an eagle now, the requirement. We have an additional requirement right now, and we are asked to implement an eagle also, which can basically exhibit all these behaviors except the sing. So how would that look? So in order to save some time, let me just get the code ready. So here we have an eagle, which is also a bird. And just like every other animal, it has to provide a specific implementation of climb, which in this case, let's say the requirement was that it can climb on towers. And it can do the normal stuff like every animal does. It can fly, but it cannot sing. So that is why it has not implemented the iSingable. And if you come to the program, I do have the eagle also doing all that is required as per the specification. And we have an eagle named Jack who is basically eating, climbing, flying, but not singing. So what happens if we try to make this eagle sing when there is no contract enforcing that? So if I say something like eagle dot, you see the sing is not even displayed in the list because it's not there in the contract. It has not implemented that. So even if I try to force it, so basically the compiler is not letting me, VS Code is not letting me do that. So even if I did force it, I do have this error and it says it does not contain a definition for sing and no extension methods. And going by the requirements, eagles are not supposed to sing. So by having these contracts well defined, we are preventing other developers from using the object of a specific type in ways they're not supposed to. So we are providing that additional layer of robustness in the application while still keeping everything very neat and tidy and understandable. Something which was not possible if we did not have the object-oriented programming approach. And this is just the beginning. In fact, we will be able to appreciate it further when we try to completely revamp this main application code using polymorphism such that it becomes very manageable, extensible, and understandable. And when it comes to the interface here, so I would just like to reiterate the fact that an interface is a pure abstract class. It can only have method signatures or declarations, but the specific implementation will be left to whoever is actually doing it. So we'll go back to the main program and we will take this off since we are no longer interested in this. And in the next video, we will see how we can refactor or in fact rewrite this code in a lot better way.